All right, y'all. Today we're going to be talking about parallel and perpendicular lines. So we've graphed lines, we've written equations for lines, we've worked with lines, and all of our three different types of equations are slope-intercept form, our point-slope form, and our standard form. We've had lines that have an increasing slope, we have lines that have a decreasing slope, we have lines that are perfectly horizontal with a slope of 0 or perfectly vertical with an undefined slope. But this last group of lines we're going to talk about is kind of comparing two lines to each other. And most two lines are just two lines, but we do have two very special results that occur, and that's parallel lines and perpendicular lines. Now, parallel lines are two lines that have the exact same slope. So we say they're parallel because they literally are going in the exact same direction. They have that same slope, which means they are increasing that rise and that run, or decreasing in that exact same amount. So we can see pretty clearly our two parallel lines. They're both going up by, it looks like, rise of 1 and run of 2, so a slope of 1/2. They're going up by that same exact amount. They have two different y-intercepts, so they're not the same line. They're two different lines, but they have that same slope. Now, perpendicular lines, on the other hand, are perfectly split. They actually make 90-degree angles with their two lines. And we say that perpendicular lines have the opposite reciprocal slope. And so that opposite means opposite sign. That reciprocal means flipped fraction. So opposite would be, instead of a positive slope, a negative slope. And reciprocal would be, instead of a 2, it would be 1/2. And I know that's a little weird to think about, so we'll see that in a little bit. It starts to make a little bit more sense when we work with the numbers. But hopefully, getting that visual, you can see pretty clearly what parallel lines are supposed to look like and what perpendicular lines. One thing I do want to dispel about perpendicular lines: all two lines that intersect like this are not perpendicular. Perpendicular lines have to have that opposite reciprocal. It actually creates that perfect 90-degree angle with the two lines when it's perpendicular. We have lots of other sets of lines that intersect, but most of them are not going to be perpendicular. Okay, so let's actually look at some examples, because with parallel and perpendicular lines, there's two things. We're going to be identifying parallel and perpendicular slope, and then we are going to be writing some parallel and perpendicular line equations. So our first set of equations, we want to write out the slopes that are parallel to each of these equations. So when I'm trying to identify parallel slope, first thing I want to do is I want to identify slope. Once I've identified slope, then I'm going to find that parallel slope. So for question 1, this is in slope-intercept form. So since it's in slope-intercept form, it is y equals mx plus b. So that m, or that slope, is always the number that's in front of x. So my m is equal to 2. Now, if I want a parallel slope, parallel is the same slope. So our parallel lines are the exact same slope. So my slope for my parallel line would also be equal to 2. Okay, so if my original slope was 2, my parallel slope also 2. So some of you might be thinking, oh, parallel, this is nice and easy. And it can be. Sometimes you do have to do a little bit of extra work, but let's look at one like number 2. We have y equals 4 minus 5x. So this one is in slope-intercept form. Things are just a little bit switched around. So this 4 is our b, our y-intercept, because it's not with the variable. This negative 5 is our m, because it is with our x. So our original slope is equal to negative 5. So if our original slope is equal to negative 5, then our parallel slope is also equal to negative 5. Okay, now looking at a question like number 3, we have 2y is equal to 3x plus 4. So right off the bat, hopefully you notice this is not in slope-intercept form. And the reason it's not in slope-intercept form is because currently y is not by itself. It has that 2 in front of it. So before I can identify the slope, I have to isolate that y. So I think, what can I do to get y by itself? Well, I can divide both sides by 2. And when I do that, every single term, remember when I divide, every term gets divided by 2. So over on the left, my 2 and my 2 are going to cancel out. Over on the right, 2 does not go into 3, so I'm just going to leave that as 3/2 x. 2 does go into 4 twice, so I'm going to change that to plus 2. Okay, and then from here, now it is in slope-intercept form, so I can identify my original slope, which is always the number in front of x, so m is equal to 3/2. And since I'm looking for parallel slope, which is the same, our parallel slope is also 3/2. Okay, so that's really, when we're just identifying slopes, y'all, that's about as hard as it can get. Having to do a little bit of extra solving first to get it into slope-intercept form to be able to pull out that slope. Nothing too crazy from there. Okay, let's flip it a little bit, and let's do what most people find a little bit more difficult of the two, which is identifying our perpendicular slopes. So when identifying our perpendicular slopes, it is the opposite reciprocal. Okay, so first and foremost, before we can get to perpendicular slope, we have to find the slope to begin with. So we have y is equal to 3x plus 4. So once again, this is in slope-intercept because y is by itself, and our x is over on the other side. That number in front of x is our slope, so our original slope is 3. And because we're going to have to find the opposite reciprocal, I'm going to go ahead and write this 3 not just as 3, but as 3/1 in that rise over run form, which we typically do when we're graphing, but we're also going to do when we're trying to identify perpendicular slopes. Okay, because the opposite part of our perpendicular means opposite sign, and the reciprocal part of our reciprocal means to flip the fraction. So the first thing I'm going to do for my parallel slope is I'm going to do the opposite sign. So currently it is positive 3/1. So my my perpendicular slope is going to be negative instead of positive. So my original slope was a positive 3. My perpendicular slope is going to be negative. Then the reciprocal is I flip the fraction. So instead of it being 3/1, my perpendicular, my reciprocal would be 1/3. So our original slope was 3. Our opposite reciprocal is negative 1/3. So 3 and negative 1/3 are perpendicular slopes. Okay, so nothing too crazy, but perpendicular does have a little bit more to it than just writing the exact same number down. So let's practice number 1. So on number 5, we have y is equal to x minus 4. This is in slope-intercept form, but you might notice there's not a number there in front of x, and that's because we get lazy as mathematicians and we don't write that 1 that's in front. So that means our slope is 1. And just like I did last time, I'm going to go ahead and write that in rise over run form, so as 1/1. Okay, and then when I'm identifying my perpendicular slope, two things. First, I got to do the opposite. So instead of it being positive, it's going to be negative. Then I flip the fraction. Now, 1/1 is already 1/1. So when I flip it, it's still going to be 1/1, which negative 1/1 would just be negative 1. So if my original slope was positive 1, my opposite reciprocal or my perpendicular slope is going to be negative 1. And that does make sense because the only thing divided by 1 is 1. So when I switch it, it's just still 1, but the sign is still going to change. Okay, last but not least, we have number 6. 4y is equal to 8 minus 7x. Now, number 6 is really similar to what we did on number 3. It's not currently in slope-intercept form. So go ahead and pause me and see if you can get this into slope-intercept form and calculate that perpendicular slope without my help. All right, y'all, and first and foremost, to get this one by itself, we're going to divide everything by 4. So we get y equals 2 minus 7/4 x. And then this is in slope-intercept form because y is by itself, but it's technically backwards. 2 minus 7/4 x. But that's okay. I can still identify my slope by the number that's in front of x. So our original slope is negative 7/4. So m is equal to negative 7/4. So for my perpendicular slope, I take the opposite sign, so positive, and then I flip that fraction. So instead of 7/4, I get 4/7. So my original slope was negative 7/4. My perpendicular slope is positive 4/7. Okay. So hopefully you kind of got the hang of finding parallel and perpendicular slope. This is going to allow us to take it to the next level, which is actually writing parallel and perpendicular lines. Okay, So once we find that slope, it's just like any linear equation. Once we've found the slope and y-intercept, then we can plug it into our slope-intercept form. Y is equal to mx plus b. Okay, if we don't have the y-intercept and instead have a different point, we can just use our point slope form. Y minus y1 is equal to m times x minus x1. So we're going to do some practice where we're not just finding that parallel or perpendicular slope, but then we're also going to write an equation with that new slope. So we're going to kind of combine the writing skills we did in the last 2 days with our parallel and perpendicular that we're exploring today. So let's go check it out, see what that looks like. Okay, so for questions 7 and 8, we want to write an equation from the given information. And let's look at number 7 first. So for number 7, we want a parallel line to y is equal to 2x plus 1, and it goes through the point 3, 3. So the first thing we want to do is we want to identify our original slope, which is in slope-intercept form. So our original slope is equal to 2. Then once I've identified my original slope, then I'm going to identify my parallel slope, which parallel is the same. So our m parallel would also be equal to 2. Okay, now the second piece is that I want to write a equation. Now I either need to have the slope and my y-intercept if I want to write this in slope-intercept form, or I need to have the slope and just a point if I want to write this in point slope form. So I have slope and a point. 3, 3 is just some point that's on my line. So I'm going to use point slope form. And for point slope form, I need to take my point and go and identify x1 and y1. And then, of course, I have my slope, which is 2. So that point slope form is y minus y1. So y minus y1, which is 3, equals m, so 2, parentheses, x minus x1, which is also 3, and then close parentheses. And if it just stated to write an equation, we could leave it right here. This is technically a point slope equation. If I really wanted to, I could move over that 3, so it's a y equals equation at least. But a lot of times you can leave it in this point slope form. Now, let's say after writing it, we wanted to maybe graph this equation, or all of our answer choices were in slope-intercept form. Then just like we practiced, we can convert this to slope-intercept really, really quickly by distributing this 2 to the inside. That would give us y minus 3 is equal to 2x minus 6. And then I can add that 3 to both sides to get y by itself. It's going to cancel out over here on the left. Over on the right, 2x stays 2x, and negative 6 plus 3 becomes negative 3. So we get y is equal to 2x minus 3. And I do want y'all to kind of see side by side the two equations. So our original equation had that slope of 2x, or 2, but it's in front of the x, so 2x. And then our new parallel line also has that slope of 2, so 2x, but then it has a different y-intercept of negative 3. So when we have those two parallel equations, that's what we should see. They have the exact same slope, but different y-intercepts. Okay. For number 8, a little bit different. This time we're doing perpendicular to y is equal to 3x plus 4, and that goes through the point 0, negative 5. So this time, once again, I have an equation in slope-intercept, so I can go ahead and identify my slope right away. So m is equal to 3. But because I'm doing perpendicular, I'm going to go ahead and write that in rise over run form, so 3 over 1. And then my perpendicular slope is the opposite reciprocal. So that would be negative because it's positive, and then 1/3. Okay, so I have my perpendicular slope. The point they gave us this time, 0, negative 5, that x value is 0, which means this is the y-intercept. So that means our b is equal to negative 5. So since I have my slope, I have my y-intercept, I can write this in slope-intercept form, which makes everything a bit easier. So y is equal to negative 1/3 x, and then minus 5. And that's really all there is to it, y'all, with these. Pretty straightforward. We're going to shift it just a little bit and not just write equations from a verbal presentation, but also write equations from a graphical representation. So let's look at number 9. We want to graph a line that is parallel to a line that is already drawn that passes through the point 0, comma, -3. So they've given us two pieces of information. They've told us the slope of the original, or they've told us it's parallel, and then they have given us a point 0, comma, -3, and that 0, comma, -3 is a y-intercept, so that's going to be good. That means our new equation can be in slope-intercept form. Okay, so we know the line is parallel, but to write another parallel equation, we have to be able to find the slope. So that first step is we're going to find the slope. Okay, so the slope of our original equation, you can see we have two clear points denoted on the graph over there. So we can take those points. We are going to rise by 1, 2, 3, 4, 5, 6, 7, and we're going to run by 1. So rise over run, 7 over 1. So that means our slope is equal to 7. And since it is parallel, our parallel slope is the same. So it is also 7. Okay, so we have the slope that we want to use for our new equation. The next thing we need is our y-intercept. Notice they give it to us right here, 0, comma, -3. So our b is equal to -3. Okay, so we can go ahead and write our new equation. Y is equal to 7, because it's that same slope, and then x, and then that b value of -3. Okay, so that's our equation of our new parallel line. But remember, we want to not just write the equation, we want to actually graph that line. Okay, so we can use our graphing skills here real quick. So y-intercept first of -3. And then I'm going to go my slope of 7 over 1. So 1, 2, 3, 4, 5, 6, 7, and then over 1. And that'll give me that second point. And then from there, I can draw my straight line. And we can clearly see, even though my line might not be perfectly through that slope, but we can pretty clearly see that those two lines are parallel. They just go through different y-intercepts. Okay, so relatively straightforward. Just to kind of go over the steps we've done that one again. First thing we did is we found the slope from the graph. Then we identified the point. If they give us a point that's a y-intercept, we can write our equation in slope-intercept form. If they give us a point that's just a random point, we have to write it in point-slope form first, and then we can convert it into slope-intercept form. Okay, then once we have our equation written, we can use our graphing skills to actually plot it onto a graph. So we're kind of combining our graphing linear equation notes, our slope notes, and our writing linear equations notes all together to be able to rock out these parallel and perpendicular line questions, which is kind of cool to see, something that pulls everything from the unit together. So with that being said, I want you to use all of that knowledge to go ahead and do 10 without me. So pause the video. On number 10, you're going to graph a line that is perpendicular to the line already drawn that passes through the point 0, comma 1. All right, y'all. So first and foremost, we want to identify that slope. So looking at our equation on our graph, we do from those 2 points they give us, which you didn't have to use those 2 points. If they give me points, I want to use those points because I know they're good. So from that point, I rise up by 6 and over by 3. So a rise of 6 over a run of 3 does reduce down to 2 over 1 for a slope of 2. But I'm going to keep it in that rise over run form because I'm trying to identify a perpendicular slope, which means I want the opposite of positive 2 over 1, which would be negative, and then the reciprocal of 2 over 1, which would be 1/2. So that perpendicular slope is -1/2. Then the second piece of information they gave us is that it passes to the point 0, comma 1. That x value is 0, so we know that point is the y-intercept, so b is equal to 1. So we have our slope, we have our y-intercept. We can go ahead and write our equation in slope-intercept form. Y is equal to -1/2 x plus 1. From there, we can use that equation to go ahead and graphing our positive 1 first. Then from our y-intercept of positive 1, we're going to go down by 1 and to the right by 2. And that will give us our nice decreasing slope. And then we can graph through all those points that we have there. And you should see pretty clearly that 90-degree angle that we're looking for right here between the two lines. That tells us that this is perpendicular slope. All right, y'all. That's really all there is to it when it comes to parallel and perpendicular. I know some of these questions like 9 and 10 can be pretty intensive, but even if you can just do parallel and perpendicular slope today, and we kind of work up to some of these a little bit later, that's a great place to be. So go ahead and complete those stations and do some practice.